more than any other planet in our solar system. From ancient astronomers who watched its red glow move across the night sky, to modern scientists sending robotic explorers across millions of kilometers of space, one question has remained at the center of our curiosity. Could Mars have once been alive? Today, the red planet appears cold, barren, and lifeless. Dust storms sweep across endless deserts. Temperatures plunge far below freezing. The atmosphere is so thin that liquid water cannot survive on the surface for long. At first glance, Mars seems like a world completely hostile to life. But appearances can be deceiving. Hidden beneath the dust and rock lies evidence that tells a very different story. A story of rivers, lakes, and perhaps even vast oceans. A story that suggests Mars was once a planet dramatically different from the frozen desert we see today. To uncover this mystery, scientists adopted a simple strategy: follow the water. Because wherever water exists, life has a chance to emerge. The search began with a series of robotic explorers sent across the solar system. These machines became humanity's eyes and hands on another world. They climbed hills, crossed craters, analyzed rocks, and drilled into ancient sediments, searching for clues preserved for billions of years. One of the most important explorers was NASA's Opportunity rover. When Opportunity landed on Mars in 2004, its planned mission was expected to last only 90 days. Few people imagined that this small robot would continue exploring for nearly 15 years. As Opportunity traveled across the Martian landscape, it encountered evidence that hinted at a watery past. Strange rock formations, mineral deposits, and layered sediments suggested that water had once interacted with the surface. But the most exciting discoveries came years later near a massive impact site known as Endeavour Crater. There, Opportunity found something remarkable. Running through ancient rocks were bright mineral veins composed primarily of gypsum. On Earth, gypsum forms when mineral-rich water flows through cracks underground and slowly deposits dissolved minerals over time. The discovery was groundbreaking. This was not evidence of a brief flood or a temporary puddle. It suggested that water had once moved through the Martian crust for extended periods. Even more exciting was the chemistry of the environment. Scientists determined that the water responsible for these deposits was likely less acidic than water found elsewhere on Mars. In other words, the conditions may have been suitable for microbial life. For the first time, Mars was no longer just a planet that once had water. It became a planet that may have been habitable. Yet scientists wanted stronger evidence. They needed to know whether Mars had supported long-lasting bodies of water capable of sustaining life over extended periods. To answer that question, NASA launched a new explorer, Perseverance. Landing in Zhurong crater in 2021, Perseverance arrived at one of the most promising locations ever selected for a Mars mission. From orbit, scientists had identified a massive fan-shaped structure stretching across part of the crater floor. It looked strikingly similar to river deltas found on Earth. River deltas form when rivers flow into lakes or oceans, depositing layers of sediment over time. These sediments are particularly valuable because they can preserve chemical and biological signatures for billions of years. If ancient Martian life ever existed, Zhurong crater was one of the best places to search for its remains. As Perseverance began exploring the region, it discovered rock formations shaped by flowing water. It drilled into ancient rocks and collected samples that revealed a complex geological history. Some of the rocks showed evidence of volcanic origins, while others displayed clear signs of interaction with water. The findings painted a picture of a world where rivers once carried sediments into a long-lived lake. Water was not simply passing through the region, it was present long enough to transform the landscape itself. This was a major step forward. Mars had not only possessed water, it had maintained stable environments where life might have had the opportunity to emerge. But perhaps the most astonishing discovery was still waiting to be made. In 2021, China successfully landed its first Mars rover, Zhurong, in a region called Utopia Planitia. This enormous basin has fascinated scientists for decades. Some researchers suspected it may once have been part of an ancient ocean. Unlike previous missions, Zhurong carried advanced ground-penetrating radar capable of looking beneath the planet's surface. As the rover traveled across the landscape, it collected data from hidden layers buried deep underground. What scientists found was extraordinary. Beneath the surface lay a series of sloping sedimentary structures extending for more than a kilometer. These layers all tilted in the same direction, forming patterns remarkably similar to coastal deposits found on Earth. On our planet, beaches and shorelines leave behind distinctive geological signatures.
Waves repeatedly move sediments, creating gently sloping layers that can remain preserved for millions of years. The structures detected by Zhurong closely match these coastal formations. Scientists carefully considered alternative explanations. Could they have been ancient sand dunes, lava flows, wind-driven deposits? The evidence suggested otherwise. The consistency of the slopes, their orientation, and their geological characteristics pointed toward a much more exciting conclusion: ancient shorelines. If the interpretation is correct, Mars once possessed not merely rivers and lakes, but vast standing bodies of water that behaved like oceans. Waves may have rolled across the Martian coast, tides may have risen and fallen, wind may have shaped beaches beneath an ancient sky. For scientists searching for evidence of life, this possibility is incredibly important. On Earth, coastal environments provide ideal conditions for biological activity. They concentrate nutrients, create chemical gradients, and offer stable habitats where complex chemistry can unfold. Many researchers believe that environments like these played a crucial role in the emergence of life on Earth. If similar environments existed on Mars billions of years ago, then the chances of ancient Martian life become significantly more plausible. Yet despite all these discoveries, a major mystery remains unsolved. If Mars once possessed oceans, where did all the water go? Scientists believe part of the answer lies in the planet's magnetic field. Billions of years ago, Mars likely possessed a magnetic shield similar to Earth's. This shield protected its atmosphere from being stripped away by the solar wind. Eventually, Mars lost that protection. As the atmosphere gradually disappeared into space, temperatures dropped. Surface water evaporated, froze, or became trapped underground. What remained was the cold, dry planet we see today. Yet enormous quantities of water may still exist beneath the surface as ice deposits and underground reservoirs waiting to be discovered. Every new mission brings us closer to understanding this lost world. Every rock analyzed, every sample collected, every kilometer explored, adds another piece to the puzzle. Mars has already revealed evidence of ancient rivers, it has revealed ancient lakes, and now it may have revealed the remnants of ancient oceans. But the greatest question remains unanswered. Did life ever emerge there? Somewhere beneath the red dust may lie the fossilized remains of an alien ecosystem that vanished billions of years ago. And if humanity ever discovers proof that life existed independently on Mars, it would be one of the most important discoveries in human history, because it would mean that life is not unique to Earth. And if life emerged twice within a single solar system, then perhaps the universe is filled with worlds waiting to be discovered. The search continues, and Mars may still have many secrets left to reveal.